This is the calculator portion of the Chapter 4 review for college algebra. The first two questions we are looking at simplifying or evaluating a log expression. We are not able to get a common base here. We are looking at log base 2 of 15. If it had been log base 2 of 16, we would have been fine because 16 is a power of 2. So we can do that one without a calculator. 2 to the 4th is 16. However, 2 to the power giving us 15 is not going to come out as a nice integer value. So we are going to use the change of base formula. Which states that we can take the log of 15 using base 10 and divide by the log of 2 using base 10. Or we could also use base e, which would be natural log. Either one is fine. You have keys on your calculator for both. Typing this in our calculator, we get 3.9069. And for number 2, using that same change of base formula, we would have the log of 82 divided by the log of 7, both of these using base 10. And again, our calculator would give us 2.2646. All right, question 3. We are solving an exponential equation, and the variable that we're trying to solve for is an exponent. One of our techniques is to get a common base. And in this first example here, number 3, we can do that because 27 is the same as 3 cubed. So I can rewrite that side of my equation, and now both sides have 3 to a power. And then I can just set the powers equal. So 2x plus 1 has to balance with 3 on the other side. Solving that, we've got 2x equaling 2 or x equaling 1. Okay, question 4, same idea, but this time we have to change both of them. 8 is the same as 2 cubed, and 4 is the same as 2 squared. So we can use 2 as our base. We're going to rewrite 8 as 2 to the 3rd power, and it is being raised to the 1 minus x power. On the other side, we can write 4 as 2 squared. It is also being raised to the x plus 2 power. Again, we need to make sure that we distribute those powers. So this really becomes 2 to the 3 minus 3x equaling 2 to the 2x plus 4. All right, we now have same base on both sides, which means our powers are equal. We have 3 minus 3x balancing with 2x plus 4. Simplifying that, we can add the 3x over. We've got 5x. Subtracting the 4 over, we have negative 1, which gives us negative 1/5 for x. Question 5. We have e to the 3x in there, but before we deal with that piece, we need to move the 2 and the negative 9. So our first step would be to add the 9. We have 2e to the 3x equaling 50, and then we could divide out the 2, and e to the 3x would be 25. And at this point, in order to solve for x, we would need to use logarithms. So we can take the log of both sides. I'm going to choose natural log since I have an e in my equation, and natural log involves base e. So simplifying this, on the left side, log base e of e to a power is just your power, so we have 3x equaling the natural log of 25, and then we simply divide out our 3. So we would use our calculators to get the natural log of 25, take that answer divided by 3, and we should get 1.073. Question 6 has a quadratic type expression here. We have e to the 2x minus 3e to the x minus 18. What we're looking for is our middle term and our first term are related. The first term has twice the power of the middle term. In other words, it's e to the x squared versus just e to the x. So it does factor. In order to get that e to the x in the middle, we are going to need an e to the x in the first position in each factor. Foiling that out, that would give us our e to the 2x. So we've accounted for that first term. To get a negative 18 but have it add up to a negative 3 in the middle, we would need a negative 6 and a positive 3. And again, you can check by foiling that out that it works correctly. We now, because it's equal to 0, can set each of these expressions equal to 0, or each of these factors. Solving, we have e to the x equaling 6 and e to the x equaling -3. And now it's very similar to the one we just did where we have to take the natural log of both sides. On the right-hand side here, we can't simplify that. We can't actually find the natural log of a negative number. We can't find the log of any 0 or negative value. So we're going to get no solution for that part of it, but we can take the natural log of 6. And again, using our calculators, we would have x being 1.7918. All right, question 7 has two separate log pieces. They're both base 6. So the first step to simplify this is to condense it down. When we've talked about condensing before, a positive sign in between two logs, we're adding two logs that would condense back into multiplication. So this becomes the log base 6 of x plus 3 times x plus 4. And now we can think of it in exponential form. So 6 to the first power has to give us this big expression. All right, and then we're going to FOIL that out. We have x squared plus 7x plus 12. On this side, we end up with just 6. And because it's quadratic, we want to get a 0 on one side. So I'm going to subtract that 6 over and then factor. So we factor it into x plus 6 and x plus 1. So my possible solutions, x could be -6 or -1. And now I need to plug those back in and double check that they truly work. So if I put a -6 in here for x, -6 plus 3 comes out as a negative value, and I can't take the log of a negative. So this one is going to be extraneous, meaning it doesn't really work. If I put a -1 in here, -1 plus 3 does give me a positive answer, so I can use that. Putting a -1 in here also gives me a positive value, so I can take the log of both of those. So this would be my only solution. And our last one here, number 8, before I deal with the log of 3x part of it, I'm going to get rid of the 4 and the -7. So we have 4 log of 3x. If I add that 7 over, I have 8. And now I can divide my 4 out. I get log of 3x equaling 2. And remember, when we have just a plain log, common log, that means base 10. So when we do our rewrite it in exponential format, we would have 10 to the second equals 3x. 10 squared is 100, so x is going to be 100/3. All right, so that gives you an idea of the types of questions that will be on the calculator portion of your Chapter 4 test.